A roar at the shoreline intake, then, far inland, silence over dunes while a buried ribbon of steel carries water where rain rarely falls. The desert pushes back. Heat expands and warps. Sand scours coatings raw. Wind swings suspended pipe right when tolerances must hold. Crews cut and weld long steel, shield every field joint, push seawater through filters and membranes, and drive it inland with powerful pumps. Misalignment or quality at one seam, and the line can leak, foul, or force shutdowns across the network. We'll unpack the sequence: intake, membranes, welding, coating, lowering, and the make or break move. The lowering sequence that sets a welded string without cracking a single seam. The mission sounds simple: take seawater, make it drinkable, and push it inland continuously. Doing it in heat, dust, and shifting ground is the hard part. Operators need stable flow and chemistry. Builders need repeatable methods that survive climate and logistics. Communities at the tap depend on constancy. Once a region leans on this supply, interruptions ripple fast. Seawater is salty enough to require high-pressure separation. After separation, the water's chemistry is rebuilt so it won't attack pipes or cause taste and health issues. If pumps trip, membranes foul, or a field joint leaks, quality and pressure fall quickly, and repairs are slow because most of the line is buried. Schedule matters too. Rework burns time twice, fixing the defect and losing production. Heat shimmer over flats, wind pushing sand along the right-of-way, distant surf marking the intake's edge, coast to desert in one system. Long hot seasons change work, windows, and curing. Sparse rainfall doesn't help the ground. It leaves it loose, saline, and mobile. Equipment derates, coatings behave differently with surface temperature and wind. At the coast, the intake placement depends on seabed stability and sediment pathways. On land, survey teams set alignments and grades. Geotechnical crews sample soils along the corridor to find weak layers and migrating dunes. Get the ground wrong and failure is quiet. Differential settlement bends the pipe. Bending concentrates stress at welds and elbows until a routine pressure cycle becomes fatigue. Design logic, the system diagram in words: 2 machines, 1 utility, a water-making plant at the coast, and a water-moving backbone inland. Intake and pretreatment: screens block debris, sand/media, and cartridge filters strip fine particles so membranes aren't sandblasted. Reverse osmosis, RO. High-pressure pumps force water through semi-permeable membranes, separating fresh water from most salts. Post-treatment, minerals and pH are adjusted so finished water is stable and non-aggressive. Transmission: long steel pipelines, boosters, storage, and valves move and buffer flow. Controls, sensors, and automation coordinate quality, pressure, and protection. Where failures propagate, a torn filter lets fines reach RO and foul it. A damaged field coating at a weld becomes a corrosion cell that grows unseen. Cause meets effect in interfaces, so they're designed to be testable and isolatable. The site is built before the project. Temporary roads, lay-down yards, in a corridor tens of meters wide become the production line for pipe. Pipes arrive in planned batches and are staged along the alignment, so welding, inspection, and coating crews never starve. The main bottleneck is access. If trucks and cranes can't move cleanly, production stalls. Planners separate haul routes, carve passing bays, and enforce one-way flows to keep lifts predictable. Dust is both a safety and quality threat. Water trucks, windbreaks, and designated clean zones protect blasting and coating from contamination. Foundation, anchoring, and ground improvement. The trench is the foundation. It must cradle, not bruise. Purpose to constraint to solution to consequence. Bedding. The pipe needs even support. Hard points and voids create point loads. Crews shape the trench bottom, remove sharp inclusions, and place bedding so the coating isn't cut. Result: fewer dents, fewer coating breaks. Pressure transients, sudden pump trips or valve slams push and pull the pipe. Restraints, anchors, tie-downs, and concrete blocks counter these thrusts so fittings and bends don't walk. Coastal buoyancy and scour. Saturated soils can lift, and moving water can erode support. Ballast, armoring, and root shifts keep the pipe seated. Quality control includes compaction checks and surveyed profiles to confirm trench geometry and bedding uniformity. The risk remains simple. Settlement leads to bending. Bending loads welds. Welds are where failures begin. In weak or migrating soils, Geotextiles and ground improvement stabilize the base and keep fines out of the bedding. Assembly line stretched across the desert. 1. Set-out aero surveyors mark centerline and grade so excavation, bedding, and placement follow one geometry. Small layout errors compound into bad tie-ins. 2. Fabricate/string to factory-made steel sections arrive coated and are laid out in sequence along the trench. A coordinated team manages spacing blocks, end caps, and orientation to control damage and contamination. 3. Fit-up/weld arrow crews align ends, set root gaps, and run root, fill yaws, and cap passes so the joint equals or exceeds base metal strength. Preheat, interpass control, and weld procedures standardize outcomes across shifting weather. 4. Inspect arrow. The joint isn't trusted, it's proven. Ultrasonic testing, UT, uses high-frequency sound to scan the weld volume and flag lack of fusion, cracks, or inclusions before the pipe ever sees backfill. 5. Coat/lower prep arrow. The factory coating stops at the bevel, so field joint coating restores continuity. Crews abrasive blast to a specified profile, check cleanliness, then apply multi-component epoxy. Edges are feathered so no step invites a coating peel. Tempo comes from parallelization. While one crew welds, another inspects. While inspectors sign off, coaters follow. Ahead of them, lowering crew stage slings and check bedding. Reported high daily weld counts only happen when these trains stay synchronized. Signature operation, lowering in and tie-in. Lowering treats heavy steel like fragile glass. Checklist with hole points. Confirm trench clean and bedding intact. Remove windblown sand in any new hard spots. Rig the string with multiple lifting machines spaced for even sag. Verify sling positions and angles within safe limits. Lift and balance in increments. Spotters call swing, surveyors call line and level. Pause to inspect field joint coating. Repair any scuffs before descent continues. Verify clearance at bends and crossings. Adjust bedding where needed. Final set down onto bedding. Release slings in sequence to avoid twist. Stop criteria are simple and strict. Wind strong enough to swing the string, sling angles approaching unsafe geometry, or avality exceeding acceptable distortion. If any appear, crews halt, rest the pipe on padded supports, re-level the trench, and recoat before resuming. Tie-ins close the gaps fast. Bevel to align to weld to UT to recoat. The integrity envelope stays continuous from factory to field. Off-site fabrication meets on-site rhythm. Pipes are rolled from high-strength steel plate, welded into cylinders, coated, and shipped as finished sections. Off-site control boosts quality. On-site planning keeps the corridor fed. Standard section lengths drive everything from truck counts to yard footprints to how many joints a welding crew must close each shift. Some routes choose longer sections to reduce field joints. Others favor shorter for maneuverability, trade-offs in handling versus welding pace. Transport constraints at the cadence, oversized loads, controlled routes, and coordinated unloads at prepped laydown zones. Safety, quality, and verification gates. Credibility comes from gates, not hope. Inspections stack, visual checks of bevels, fit up, and weld profile. UT scans confirm weld integrity, coating holiday detection, a pinhole test, finds thin spots before backfill. Pressure and leak tests validate completed sections before tie-ins link them onward. Traceability binds it together. Weld maps link each joint to welder AD UT results and coding batch tags so a problem trend can be isolated to a day, a crew, or a material lot. Example defect pathway, lack of fusion at the root or a small coating void at the field joint edge. UT flags the former, holiday detection flags the latter, before either disappears underground. Parallel pump trains with storage and automatic bypass let operators isolate a fault without draining supply. Controls synchronize starts, modulate valves, and manage transients so the pipeline isn't shocked by sudden changes. Instrumentation, pressure, flow, differential pressure across filters, and online quality becomes the operator's senses and alarms. Commissioning, testing, and first-run commissioning climbs a ladder. Component, spin motors, stroke valves, calibrate sensors, verify interlocks, and power fail-safes. Subsystem, run intake, pre-treatment, RO, and post-treatment in stages. Circulate pipeline sections, improve controls. System, introduce real flow, watching pressure profiles, vibration, turbidity, and differential pressures. During ramp-up, intake screens and cartridge filters act as shields, and operators track differential pressure to spot clogging before it reaches RO. Chemistry is tuned in small steps so downstream materials aren't shocked. Then the payoff. First, stable flow into the backbone. A controlled rise, instrument steady, no alarms creeping. From there, reliability is a discipline. Routine monitoring, cleaning schedules for membranes, pigging or flushing where designed, and planned maintenance windows that keep availability high. The build ends, the life cycle begins. Inspection intervals, corrosion monitoring, and upgrades that keep a desert nation's taps running long after the last backfill settles.